welcome back to another Algebra 2 lesson. This is Special Functions Part 2. We're going to begin with example 4. We're talking about graphing greatest integer functions. So greatest integer functions have these double brackets around them. They look a little bit funny, but all that means is that when we evaluate numbers in here, what we're going to do is we're going to round down to the nearest integer value. So if you look at this table that they've prepared for you in your workbook, they have made it so that your x values are between -1, including -1, and go up to -0.5. Now let's think about why they would choose these values. Let's begin by plugging in -1. 2 times -1 is -2. -2 minus 1 would be -3. Therefore, the answer is -3. So they go all the way up to -0.5, but they don't want to include it. So why wouldn't they want to include that -0.5? Well, let's plug it in and see. 2 times -0.5 is -1. -1 minus 1 is -2. We're rounding to the nearest integer value. So we just actually figured out the value that goes in our next one. But let's think about -0.6. because that would fall in between -1 and 0.5. So I'm just going to plug it in the calculator here. We've got 2 times -0.6 minus 1 is going to give me -2.2, if you can see that. So -2.2, we have to round it down to the nearest whole integer value. So it's tempting to say -2 because -2.2 is closer to -2, but we're rounding down. We got to round down. So -2.2 falls between -2 and -3, so we round it down to -3. Same thing here with all the values that are going to fall in between -0.5 and 0. We're going to round it down to -2. So like if I plug in -0.4. So we've got 2 times -0.4 minus 1 gives me -1.8. We're going to round that down to -2, down to the nearest integer value. Even if I did -0.1, 2 times -0.1 minus 1 is -1.2. It's tempting to say, well, that's closer to -1, so I want to round to -1. We've got to round it down to the nearest integer, so it's -2. Looking at 0 up to 0.5 inclusive, we'll just plug in the 0. 2 times 0 is 0, minus 1 is -1. Let's plug in the 0.5. 2 times 0.5 would be 1. 1 take away 1 is 0. We can fill it in. 2 times 1 is 2. 2 take away 1 is 1. And I'm starting to see a pattern here. -3, -2, -1, 0, 1. So this one is going to be 2. Check your answers, and they are correct. So now that we've got our table of values, now we can graph them. So let's make a graph. Let's think about how would you graph this? What this is saying, for any x value that's between -1 and -0.5, the corresponding y value is going to be -3. So this is going to look like you're going to have a horizontal line from -1 to -0.5 that is going to be paired with -3. So let's graph that. Looks like they've done it for us. -1 goes down to -3 all the way up to the 0.5, -0.5. And notice they included this part, but they left an open circle over here, because if we look back up at our table, we don't want to include that -0.5 on this part. We want to include it on this part. So now we're going to jump into our next section. We've got all these nice little steps. Beautiful thing. Notice each end is including on the left-hand side, but on the right-hand side, we're excluding the point. All right, so now we have to state our domain and our range. Well, it looks to me like our domain is going to be, according to the values that we looked at, starts here at what value is this? Our x value, I believe it was -1 was the lowest x that we looked at, and went all the way up to +2. But we know that this could keep on going. Just because we chose these values doesn't mean that we couldn't choose more. We could keep on going down, we could keep on going up. So our x, our domain, is going to be all real numbers. And the range, though, however, it's not going to be all real numbers, because notice I don't have any values in between the integer values. I have an integer value of what is this? -4, -3, -2, -1, 0, 1, 2. So we can't say it's all real numbers because it doesn't include the numbers in between. Instead, we would say the range is all integers. All right, so let's look at the next part. Graphing absolute value functions. I think absolute value functions are kind of fun to look at. An absolute value function is a function that contains an algebraic expression within the absolute values. I always think of goalposts. When you get that ball between the goalposts, that's a positive thing for your team. You're getting points, right? You're going up. It's a positive thing. So whenever the numbers, whatever we plug inside of there, even if it results in a negative, once it spits it out, it's a positive thing. It's a positive thing. Because what absolute value is talking about the distance a number is from 0 on the number line. That's always going to be positive. We don't say travel -1 miles. We say travel 1 mile. When we're talking about distance, it's always positive numbers. All right, so looking at this, it says for the absolute value function, this absolute value of x is known as the parent function. It's the simplest one we can get. So then if something happens outside of the absolute value, if we add numbers, that shifts it up. If we subtract numbers, that shifts it down. Hopefully you remember this from Algebra 1. If we do something inside of the absolute values, if we add a number, that shifts it to the left that many units. If we subtract a number inside of the absolute values, it shifts it to the, did I say add? If we add, it shifts it to the left. If we subtract, it shifts it to the right. It's the opposite of what you would think it would be. So outside is exactly what you would think. Adding, it goes up. Subtracting, it goes down. Inside the absolute values, adding shifts left. Subtracting shifts right. All right, so let's look at this. Graphing the parent function. If I plug in a 1, I get out a 1. But also if I plug in a -1, the absolute value of -1 is +1, hence the V shape in our graph. Okay, so let's look at some things here. We got a piecewise function here. The absolute value is a piecewise because we have this piece and we have this piece. The blue piece is for all of my values of x that are less than or equal to 0, and or less than 0, and it has a downward slope, has a negative slope. Okay, the orange piece is for all of my x values greater than or equal to 0, and it's going up. It has a positive slope. So if we're looking at it as a piecewise function, this would be our function. Thinking about the domain and the range, my domain is all real numbers. Every x value is a possibility. But if you think about the range, the y values, where does my graph start? It starts at 0 and it goes up forever and ever. So my range is all numbers greater than or equal to 0. So we can say f of x such that f of x is greater than or equal to 0. Or if we're putting that in interval notation, we can say including 0, so I use the bracket, all the way up to positive infinity. Can't include infinity, so I use a parenthesis. And my intercepts, I only have one intercept, and it is here at 0, 0. All right, let's move on to example 5. Graphing an absolute value function, positive coefficient. So the absolute value function has a positive coefficient. So we know that the slope should be positive, right? But then we also know that on that other piece, it's going to be negative. So, it's interesting. We got two different ways that we can think about this. We can use a table or we can graph it by cases. We can look at the negative part that's going to shoot out in a positive answer, or we can go ahead and make the table. Okay, so plugging in values, -2, or I'm sorry, -4. If I multiply those together, I get -3. But then the absolute value of -3 is a +3. So 3 plus 3 is 6. So when I plug in a -4, I get out a 6. Plug in a -2. Now I'm going to have -6/4. -6/4, take the absolute value of it, I get a +6/4, which is 3/2. 3/2 plus 3 is the same as 1.5 plus 3, which is 4.5. Plug in a 0, I get 0. The absolute value is 0. Plus 3 is 3. Keep on going, and there it is. So here's my table of values. What I like to think of is I know the parent function has the vertex at 0, 0, and it goes up 1 over 1, up 1 over 1, also up 1 over 1 this way. So this plus 3 tells me it's going to shift up 3, but this tells me that instead of going up 1 over 1, I'm going to go up 3 over 4 to my next point. So that's another way of looking at the pieces or looking at the graph, which is our next example. We can graph all of those, but think back to what I just said. That plus 3 tells me my vertex is going to shift from 0, 0 to up 3. 1, 2, 3, there it is. And then my rise over run, go up 3 over 4. So up 1, 2, 3 over 1, 2, 3, 4. And because it's absolute value, I know that I can also go up 3 and over 4 in this direction. And what do you know? It matches. I have more points this way, but I still get the exact same graph. So using the table, plot the points. Now what we can do is state the domain and the range. So what is my domain? Looks like all x values. Any x that I plug in, I'm going to be able to find a corresponding y somewhere on my graph. So my domain is all real numbers. But my range is a little bit different. My graph shifted up, so my range should shift up. My range is f of x such that f of x such that f of x is greater than or equal to 3. All right, so now let's look at example 6, graphing an absolute value function with a negative coefficient. So remember, think about that when it had a positive coefficient and it was a upward v. Hopefully you remember from Algebra 1, if we have a negative coefficient, what's going to happen? Think about that for a minute. So determine the two related linear equations using the two possible cases for the expression inside the absolute value symbol. So thinking about what's inside of here, x plus 1 could be positive, and so then we times it by the -2, getting -2x minus 2, or what's inside of here could be a negative value, and we just know that it shoots out as a positive. So my second case then is saying, okay, if this is negative inside of this absolute value, negative x plus 1 makes it a negative x minus 1. We're distributing that negative to both numbers, then timesing by the -2 that's out there. So negative times a negative makes it a positive. A negative times a negative makes it a positive. All right, so we've got our two cases. If we're wanting to look at this as a piecewise function, we've got the positive piece, we've got the negative piece. So now let's look at them. So let's set case 1 equal to case 2. So we set case 1 equal to case 2. Notice this is my case 1 that we just found in that previous problem, -2x minus 2 and 2x plus 2. We set them equal to each other. So now we're going to add 2 to both sides. We're just trying to solve for x here. So add 2 to both sides, I get 4. Subtract 2 from both sides, I get -4x. Divide both sides by -4, and I get x equals -1. So then that allows me to know at what point does my x value change. So if x is less than -1, then this is the part that I'm going to use. But if x is greater than or equal to -1, then this is the part that I'm going to want to use. So what this is telling me here is that this x value, when I solve this, this x value is my constraint. That tells me that's the value where it's going to change from going up, going down, or however it ends up being. That tells me that that is the key point where my graph is going to shift. So that's why we have to let this be less than -1 and greater than or equal to -1. And you might be thinking, well, how do I know which symbol to put in here? Well, we could, if you forget, if it doesn't make sense to you, you can always go back to the original problem and plug in -1. -1 plus 1 is 0, right? Then take the absolute value of 0, I get 0. -2 times 0 is 0. So when I plugged in a -1, I got out a 0. We'll put a point there, right? Okay, so then same thing with this one. I mean, I'm still going to get 0. So we know that's either the bottom point of our V shape or it's the top point. It's where it's shifting. It's where it's changing. If we plug in a value that's less than that, let's say -2. -2 plus 1 is -1. But when I take the absolute value of -1, I get out a +1. +1 times -2 is -2. So I plugged in -2 and I got out -2. So think about that on the graph. I want to go over -2, down -2. So we're going to be going downwards on this side. And we're going downwards on this side. Hopefully you recall that if I have a negative coefficient, it flips my parent function upside down. So it went from being a V to looking like a mountain. All right, so let's keep moving here. We graph it. Here's my orange line. And here is my blue line. So state the domain and the range. Once again, we can see that my domain is all real numbers. My range this time is going to be starting at 0 again, but now it's all the values less than 0 because it's not going up, now it's going down, so it's going to be less than or equal to 0. All right, and that takes us up through the rest of this lesson. I hope that made sense. If not, go back and watch it again a couple times. Just try to maybe take it a little bit slower. Pause the video. If you have questions, write them down. Send them to me in an email or bring them to class and ask me a question in class. That's the downside of all of this video lessons. You can't stop me immediately and ask me a question, but jot them down if something didn't make sense and let me know and I will try to explain it to you again. So real quick, the exit ticket here, I'd like to fill in the blanks with the information provided. So my function, we can see this is linear. So which one of these is a linear function? Clearly it is the y equals x. So that's going to be this one. This is an absolute value function. So it's going to be y equals the absolute value of x. This one's already given to me. And we can see this is a step function. So it's going to be this one. All right, so then the next says, well, what's my intercept? We can see that our intercept is 0, 0. Here our intercept is 0, 0. Here I've got two different intercepts. I've got an intercept of 1, and I've got an intercept of 1, 2, 3. However, this one's an open point, so we're only going to focus in on this one, and it has an intercept of 0, 1. And then my next one, what is my intercept here? 0, 0 again. All right, my x-intercept is at 0, 0. It's at 0, 0. There is no x-intercept here, and my x-intercept here is this little interval from 0 to 1, not including 1, but including 0. So that would be this. Okay, my domain. My domain for each of these first three, is all real numbers. So negative infinity to positive infinity. This one, my domain, my x values, looks like it's all real numbers as well. So all of these are going to be from negative infinity to positive infinity. And last of all, my range. This one's all real numbers. This one is all real numbers. This one is all numbers greater than 0. So that would be this, from 0 up to positive infinity, including 0. This one looks like it starts at 1 and goes up to positive infinity. So let's see. I don't see that. That's not a choice, is it? So starting at 1 up to positive infinity. And then this one is all integer values. Oh, yes, it does have it. Sorry, it's already written there for me, which is why there's not a choice up here. And then this one, looking at my range, it's integer values. Notice we don't have anything in between the integers. So let's check our answers, and voila, there it is. All right, that's all I have for today. I will see you guys next time.